Let's see. We are doing implicit differentiation, and we have this function here. So the idea here is we can't isolate y to do the derivative with respect to x on it. So we are doing the derivative of both sides and then applying the chain rule or the product rule or whatever types of derivative techniques we need to for each of these terms respectively. So let's just go ahead and write things out real clearly. We have that we're doing dx of the entire function. And what you do to one side, you do to the other. We're doing the derivative with respect to x to both sides. All right, so on the right side here, that's just 0. So this is going to 0. On the left side, it's basically the derivative of each of these parts. So we're doing the derivative of the first part with respect to x. We're doing the derivative of the second term with respect to x. And the derivative of the third term with respect to x. All of this is now equal to 0. So the technique that we're doing here, and what you should recognize, is that this first term right here is a chain rule, because when we do the derivative of y, it's a y squared. So we'd have to do the derivative of the y squared first, then times the derivative of the inner function. Okay. The derivative with respect to x of the second term is pretty straightforward. That's just our power rule. And then this third term here is a product rule. We have to do the derivative with respect to x of the first term and the first product and the second product. And we'll go ahead and apply the product rule to that. All right, so the first one, we have the original 2 that's out front, and the derivative of the outer function right here, the 2 goes in front, and it goes down by 1. So that's just y to the first power times the derivative of the inner function, which is just y. So we would call that dy dx. And that's our goal, is we needed to get that into play. All right. In the second term, the 2 moves out front. So that's a negative 2x. And there's nothing else on the inner side of that. Derivative of the inner function is just 1. And then on this last one is our product rule. So the derivative of the first times the second. The derivative of the first is 3x squared times the second, plus the derivative of the second, which would be dy dx, times the first. All this is equal to 0. All right. Let's go ahead and I'm going to simplify and move things to the other side. So when I simplify here, this gray is not impressing me. They changed the colors on this. So when I simplify here, I'm going to be adding 2x to both sides. And I am subtracting 3x squared y minus 3x squared y. All of that gives us, we have our, and I'll multiply this out, that's 4y, and then we have our dy dx, plus, so all this middle stuff's gone, plus this last one, dy dx, x cubed, equals, and then the things that don't have the dy dx is left on the other side, and that would be a 2x minus 3x squared y. Okay. Now, we need to factor out the dy dx on this left side. I'm going to go ahead and do my work over here now. So we have dy dx pulled out. What's left? We have the 4y, and we have the plus x cubed. Equals, on the right side, we still have the 2. Let me go ahead and do want a clear screen. And you have any other options? Where's my erase? Oh, I don't even see my erase button. All right, 2x minus 3x squared y. All right, and then we want to divide out. We want to get dy dx by itself. So that's a times 4y plus x cubed. So I'm going to divide that by both sides. Divide the left side by 4y plus x cubed. Divide the right side by 4y plus x cubed. So now I have dy dx is equal to 2x minus 3x squared y over 4y plus x cubed. Now, sometimes they're asking you to plug in values on these. If you're asked to plug in a value, then we would plug it in at this final step here. All right. And let's see, what are our choices? 2x minus 3x squared y. 2x minus 3x squared y. 4y plus x cubed, just making sure nothing else. Everything else looks good. So A looks like R. Matcher. Hey, and there's the eraser button I was looking for earlier. Good. Got it. All right. And here's where we would plug in the values, but the process is exactly the same here. You have to do the derivative of both sides. And this one would be a chain rule I did. This one would be a product rule. And then this is just our straight power rule. And how do I stop now?